Hi Unite, in this video I'm taking a look at a tricky 3D trigonometry question which tells us that a bowl is in the shape of a hemisphere or half sphere with radius 10 centimeters. The surface of the water in the bowl has a radius of 7 centimeters. How deep is the water? And we're asked to give our answer to one decimal place. Now, often the hardest part with 3D trigonometry questions is finding where the relevant right-angled triangle is. And in situations like this where we're not given a diagram, the first step is to draw up a diagram to represent the situation and then see where the relevant right-angled triangle is. So let's start by drawing up this bowl. So here's my attempt at a hemisphere for our bowl. And what we're told is if we go from the center point of the top of the bowl and we go over to the edge of the bowl, that distance is 10 because that's the radius of the bowl. And the nature of a sphere means that if I take any line that goes from the center point of that bowl over to the edge of the bowl, I know that that's always going to be 10. That's always going to be the radius. Now, the next piece of information to overlay onto this diagram is this water line. So we're told that there's a water line, which I'll represent here in blue. Maybe I'll just highlight this in blue just to represent the water. So this is the water within the bowl, and we're told that the radius of that, or in other words, if I go from the center point of where the water is, the top of the water, and then go from there over to the edge of the bowl, we're told that that distance is 7. So I'll overlay that. That's a distance of 7. And what we're really being asked to find is the depth of the water. So really from the top of that center line all the way to the bottom of the bowl, that is the length that we want to know. I'll call it D for depth of water. And really, because we know that the distance from the top of the bowl to the bottom is 10, and we want to know the distance from the water to the bottom of the bowl, if I can find the distance from the top of the bowl to the top of the water line, which I'm labeling here, I'll label it as x, just for our unknown. If I can find x, then we know that the depth, d, will be equal to 10, the radius of the whole bowl, minus x. So really, if we can find x, if we can kind of overlay onto this diagram a relevant right-angled triangle that will let us find x, then we will have everything we need to get the depth. And I think this is the trickiest part of this question, but the real light bulb moment is to notice that if I go from the center of the top of the bowl over to the edge of the bowl at the point that intersects with the top of the water line, that distance must also be 10 because that's another radius. And so here we have a right-angled triangle where we know two of the sides and we want to know the third side, so Pythagoras' theorem will help here. I might just redraw this triangle just over to the side so that we can use Pythagoras. It'll just be a bit cleaner, I think, a clean version of this triangle. So we've got a right-angled triangle. We know the bottom side is 7, the hypotenuse is 10, and x is what we're trying to find. So we can use Pythagoras. We know that the hypotenuse squared is equal to the sum of the squares of the other two sides. We want x, so we'll say x squared is equal to 10 squared minus 7 squared. And then if I take the square root of both sides, I'll have x is the square root of 10 squared minus 7 squared. Now that we have x, we can plug that into the formula that we came up with for d, the depth, and then we'll have our answer. So d is equal to 10 minus x, and we just worked out that x is the square root of 10 squared minus 7 squared. So this is what we'll plug into our calculator. So we'll go 10 minus the square root of 10 squared minus 7 squared. And we get the answer as 2.9 if we're rounding to one decimal place. So that will be 2.9 centimeters, and that's rounding to one decimal place. So that's approximately, it's an approximate answer given we've done our rounding. But that is how you answer that question. So hopefully now that you've seen how to draw up the diagram to represent the situation, you can see how questions like this become quite simple. There's not a lot of working out required. The really hard part is just finding that right angled triangle. So hopefully that explanation has helped, and tick boom.